All right, this week we're going to be looking at large sample spaces, and we're going to be kind of figuring out what do you do if you can't list all the options, because sometimes it takes a while to make these diagrams, and if there's a way we can think about it with less things being written, probably will be a lot more useful for you. So in this very first example, I'm going to say, what is the probability of rolling three of a kind with three dice? Now we're assuming a typical six-sided die here. At first it seems like, okay, we can do that. All I need is the favorable outcomes over the total outcomes. So let's look at the favorable outcomes. If all three numbers are the same, well, there's six ways to do that. All ones, all twos, all threes, all fours, all fives, all sixes. So the first half of that probability calculation, done. The top is 6. But the bottom is a little harder for us to figure out. So if I start trying to list out all the different combinations, so this would be I had a roll of 1, and then the second die was a roll of 1, the third die was a roll of 1. And then I change out the last one for a 2. And then I invert the second and third roll. And then I make the last roll a 2. You can see as I go through this process, I'm trying to do it in a special way so that I can get all the way through this list. Once I've used up 2, I know I have to go up to a 3. I have to include a bigger number. I'm going to switch the back 2. I've already switched them, so I'm going to move up to another number, 3. And you can see that our list will continue to go on. Now that I've introduced a 3, I want to go back and introduce a 1, and then I want to switch the 1 and 3 so that I can remember to include that combination. But where do I go from here? And now that I have that 1 and 3 and I switched it, what's my next option? I don't know. 1, 2, 2. Oh, wait, no, I already used 2. So you can see how I'm less than 10 into my list here, and I'm already confused about where to go next. I started trying to repeat myself. We're just getting into a bad situation here. So we're going to refer to the math greats. George Polya is, if you do any math in the future, that he's a really great read. Now, granted, he's not the current living version of a math advisor, so you wouldn't be able to ask him questions. But George Polya wrote a book called How to Solve It, and I read it, and it was very inspiring. I recommend Interlibrary Loan when the libraries open up again. He's from Princeton. But here's the advice: solve a simpler problem. Make an orderly list, consider special cases. These are just some of the things that he talks about in the book. So we're going to do each of those things. So the simplified case is, let's say it was only two six-sided dice, because we could make a list if I only had two dice that I was rolling. It wouldn't be hard to make that list. So with just two dice, here's my sample space. They could both be a 1. I could get a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Matter of fact, that first roll could have been anything, and I'll get 1 through 6 as 6 unique outcomes for that first roll. So that's how I've organized this list. The first die was this, the second die was this. And we can clearly see that there were 6 doubles where all the dice were the same, and there were 36 total. So we're going to see if maybe that helps us a little bit. Now I add on that specific condition. What if the third die was a 1? Well, I can go back to all of these 36 outcomes I had and just throw a 1 in front of it. There's my third die. What if that third die was 1? Now I have 36 outcomes for if the first die was a 1. Well, you know what? Only one of those are all the same. So 1 out of those 36 was the same. Wouldn't have to be a 1. What if it was a 2? 36 new outcomes. If that third die is a 2 and only one of them was a triple. So notice I put this little cumulative total here. I'm just putting together what if it was a 1, what if it was a 2. If it were a 3, hey look, same exact thing. 1 out of the 36 options is a triple. Again, cumulative total, I'm just adding up all of the different outcomes. I had 36 outcomes if I had a 1, 36 outcomes if I had a 2. Very predictable from here. If the third die is a 4, I have 36 new outcomes that I'm adding to that cumulative total. If there was a 5 on that next roll, I added another 36 to the total. If there was a 6 on that last roll, then I added another 36 to my total. So if you look back at all of the different possibilities here, 36 for 6 different rolls, I end up with 216 as my cumulative total. So 6 were favorable. There were 6 triples that I could have got. There were 216 possible outcomes. By dividing those, I get 1 out of 36, or 2.8%. So we were able to take something very large. I couldn't have listed 216 things in a list, but I was able to list 36 and then just put a third die in front of it for each of the possible conditions. Now, I wouldn't expect you to do this. I'm doing this to show you. Your application of this would be in your head. Okay, 36 outcomes, and then I had 6 different conditions on my last die, so 36 times 6, bam, 216. And if I use the probability tree, as you can see here, it took a little bit of effort for me to get this graphed out, but on your first roll you had 6 options. Each of those has 6 options coming out of it, and then each of those 6 options has 6 options coming out of it. So that's why you end up with this multiplication type thing. 6 options for each die gives you 6 times 6 times 6 possible outcomes. So the shortcut here is to just multiply the possible number of outcomes for every event. There were 3 dice being rolled, so I had 6 for this one, 6 choices for this one, 6 choices for these ones, so 6 times 6 times 6 is 216. And that's the shortcut that I want you to use. You don't have to spend your time making any of those things that I just made. You don't have to do this tree. I just wanted you to visually be able to see why we're getting 216, why we're doing 6 times 6 times 6. And now that we've seen it 2 different ways, we'll see why it works. So let's put it into practice. Yahtzee, classic. Love that game. I also like Farkle, but Farkle's a little harder to get probability on. So in Yahtzee, you roll 5 dice. 5 of a kind in one roll with 5 dice is what I'm asking you for the probability of. So let's just make that same exact fraction we made before, favorable outcomes over total outcomes. But this time, instead of going through all of the calculations on the bottom, I'm just going to say, well, I know there's 6 options for every die, so 6 times 6 times 6 times 6 times 6 is 7,776. And I didn't have to draw a really complicated diagram to get that. I just knew omega is going to be made up of multiplying all of my options together. Then I can do one step of simplification now that it's a fraction. Voila, 1 out of 1,296. So you're going to have to play a lot of games of Yahtzee if you want to see this happen. And again, these are just expected outcomes. It doesn't mean that you're going to have to do this many rolls exactly in order to get this. It could happen in fewer rolls. It could happen in more rolls. It could be 5,000 rolls before you see one of these. This is just the expectation that we're looking at in probability. So as you go ahead and kind of look at the overall pictures we see here, this is what you're going to be looking at more in your homework assignment that you see. You could also list it out in this way so that it's a little more countable. I'm looking at 4 options that were doubles, and then I'm going to be visualizing it in my head trying to add a third die onto that. So if I said I'm rolling a third d4, you would be putting another number in front of these, and you'd be saying, okay, if there was a 1 in front, what would my situation be? If there were a 2 in front, what would my situation be? So that's what you're going to be seeing when you do your homework assignment. If I go to D6, rolling some 6-sided dice, you'll notice that there's more options to choose from now. So if I got a 1, well, now I'd have 3 ones. If I got a 1 here, I'd have a pair of 1s. If I got a 1 over here, I'd have a pair of 1s. So that's what you're going to be doing, but you're going to be visualizing it. Instead of having to draw it out, I'm going to give you this chart and say, this is the simpler part. This only has 2 dice. Think of what would happen if you put a third die in the mix. And then the final problem that you're going to see on your homework is 10-sided dice. So you're going to have 3 10-sided dice. But you're going to understand the pattern by the time you get to this problem. So don't be too freaked out by it. These are nice tables. Feel free to use them. And good luck on your assignment this week.